Hello friends and welcome to this series on random variables on your channel GATEquestionsECE. So the next question is having question code 115 and this question was asked in year 2012 in GATE exam for 1 mark. So let's see the question. Two independent random variables x and y are uniformly distributed in interval -1 to 1. The probability that the maximum among x and y is less than 1 by 2 is, we have to find out which of the option is true. This question is very easy to solve for those who have watched my previous video on question 114, and in that question I gave a practice problem which was for three random variables and interval was -1 to 1. So those who have watched that video, this question is very easy. So let's see how to solve this question. So it is given that x and y both are uniformly distributed in interval -1 to 1, and also both are independent. So we have to find out probability that maximum x comma y less than 1 by 2. So considering this another random variable as z. So z is maximum x comma y. We will have to find out probability that z is less than 1 by 2. You can observe here that x and y are independent and also they are identically distributed. So this is a case of i.i.d random variables, independent and identically distributed random variables. So in case of i.i.d random variables, we know that the PDF of x for some sample values, say small z, will be equal to the PDF of y for same sample value small z, and also the CDF of x for sample value small z will be equal to the CDF of y for same sample value small z. And also from the previous discussion, we know that if z is maximum among x and y, then the CDF of z for independent case will be equal to the CDF of x for same sample value z multiplied with the CDF of y for same sample value z. And since fx of z is equal to fy of z, so in place of this fy we can write fx. So this will be nothing but the fx of z raised to power 2, which is the result we derived that the CDF for i.i.d case is nothing but the CDF of any one random variable raised to power total number of random variables. So here there are two random variables, so here it will be 2. So now all we need to find out is the CDF of x, and from the definition of uniform distribution we know that the PDF of x for some sample value small z will be equal to 1 by 2 in range when z is lying in -1 to 1 and 0 for all other values of z. From this PDF we can calculate the CDF, and the relation is that the CDF of x for sample value z will be equal to integration minus infinity up to the sample value small z fx lambda d lambda, where lambda is a dummy variable here. So integrating this function, we will get the CDF of x z will be equal to, so we can see here, if z is less than -1 for values less than -1, fx of z is 0. So below -1, so for the value of z less than or even equal to -1, fx of z will be 0. And for the values greater than equal to minus 1 and less than equal to 1. You can observe here we have to integrate it. So integrating, we will get 1 by 2 and we will get constant lambda, and lambda of lower limit will be minus 1 and upper limit will be z. So that will give us z plus 1. So this is the value of CDF in this range. And for z greater than equal to 1, you can see you will get it will be 1. So this is the CDF of x, and this is also the CDF of y for same sample value z. So putting it here, we will get fz of z will be equal to, so we will have to square all these. So it will be 0 square will be 0 for z less than equal to minus 1. And squaring this, we will get z plus 1 whole square divided by 4 for range minus 1 less than equal to 1, and 1 for z greater than equal to 1. So this is the CDF of z. You know, by the definition of CDF, this is nothing but the probability z is, capital Z is less than equal to small z. And also for the continuous random variable, equal to probability capital Z is equal to small z is 0. So this is also equal to probability that capital Z is less than small z for continuous random variable. So you can observe here we need to calculate this probability. So this probability, you can compare these two expressions and you can observe that this probability is the probability that capital Z is less than equal to 1 by 2. So the sample value small z here should be 1 by 2. So by putting small z 1 by 2 in this expression, you can find out what is the probability. So putting here 1 by 2, so that will give us 1 by 2 plus 1 whole square divided by 4. So this will be 3 by 2. So 3 by 2 square will be 9 by 4. So 4 into 4 will be 16. So this is the correct answer. So the correct option in the given question is option B. So I hope you have learned how to handle such questions in GATE exam. So if you like this method of solving, so do press that like button below this video if you like this video solution, and please do subscribe to my channel for more such videos in future. I'll be bringing more such problems in future. So keep in touch for more such videos, and thank you for watching this video.